That was just a little bit about introduction to LRFD versus ASD. So now we're going to dig into actual design. So personally, my favorite, Flexure design. But I mean, we have to design for everything. But let's start out with Flexure. And we're going to look at the plastic moment of resistance, or the plastic moment. So as we increase loads onto this beam, we're going to get a yield stress diagram, sort of similar to this. So we keep loading and loading with a moment. So let's say the top flange is going to be in compression and the bottom flange is going to be in tension. So we keep loading and stressing it until we get to the yield strength. So the initial yield is just going to be My, which is going to be the section modulus times Fy. So as we keep on loading this, we can actually get up to the plastic moment, or we can get to plastic hinging, in other words. So we can't increase the stress here. So instead of increasing the stress to say out here, because we can only get up to the yield strength, we actually start flattening out until we get a totally flat stress diagram. So as we keep increasing the loads, we might have something like this, for instance. And then for our next load pattern, it goes out a little bit more and a little bit more until finally we get to this plastic hinge. So as you are applying more and more stress, there is the first yielding when residual stresses are accounted for, and that's going to be MR, which is going to be 0.7 times My. So you can see these are the same equations here. MP, therefore, is just the plastic section modulus Z times Fy. This isn't as important, but I suppose it's good to know. The shape factor is defined as MP divided by My. I wouldn't expect any direct questions on the test in this, but it's sort of good to know if you need to, do some first check of S times Fy for, testing some design. And you know that you've got maybe about 12 more percent. So if you're, 1% overstressed just using S times Fy, then if you've got something where you can get up to this plastic strength of this Z, then perhaps you might get something to work.